Dear student, today we will study about electrostatics, in which special topic is capacitance. But before going to study about the capacitance, it is very important that we have to study about the behavior of the conductor in an external electric field. So let's start the properties of conductor in external electric fields. So the first property of the conductor in external electric field is the net electric field inside a conductor is zero. So this is the first property. You can say the first behavior of the conductor in the external electric field is that net electric field inside a conductor is zero. Suppose that I have a positive charge plates and charge is distributed over the surface of the plate. Then what happened? It has some electric field. It has some electric field around the charge plates. Now I want the behavior of I want to place conductor in the electric field. So I place a conductor near the charge plate. Then what happened? This conductor has atoms, and atom has nucleus in which positive charge, and outermost orbit has some electrons. When you placed near the charge plate, then what happened? These electrons are moves towards the positive charge plates. You can say that this electrons comes near this sides, and so this electrons is moves at this surface. Now what happened? This is positive charge which is enabled to move opposite sides. Then how positive charge are generated? The extreme sides of the conductor, you can say that actually it has positive charge and it wants in the electrons to neutralize its. So nearer the charges which has positive and near the atom, near this charge another atom, and this takes electrons from this atom and this becomes neutrals. This atoms becomes neutral, and you can say that there is no charge here, net charge at this point. Again this positive charge and negative charge, and because since electrons is moves at this point and it becomes neutral, and only positive charge are placed here. Now what happened? This again not at the extreme position. So what happened? This takes electrons. This takes electron nearer to the atom, and it becomes again neutralized. So it again neutralized, and again its positive charge shift at this point. So this process is continue till this positive charge is not reached there. So in this way negative and positive charge are developed at the extreme points of the surface A and B of the conductor. So in this way this process is continue till, and in this way you can say that surface attain positive charge, this also attain positive charge and positive charge. So you can say that this is the electric field, external electric field E. This is line show the external electric field, and because the positive charge at this surface and negative charge at this surface, so it also create a electric field from positive to negative in this sides. You can say that inside the conductor it induce a electric field line. So net electric field line, you can say that this is external electric field and this is induced electric field inside the inside the conductor. So suppose that this has 100 and this is 10, the net becomes 90. Then net what happens, this is in this directions and its direction is opposite, so net electric field becomes 90. It means electric field is reduced. This process is continued because this electric field did flow the negative electrons in this direction, so more electrons are attained at the surface A and more positive charge attained at surface B. So again electric field inside the conductor is induced, and this process continue till it not becomes equal to the electric field inside or outside. So net electric field inside the external electric field and internal electric field line becomes equal, so it cancel out and net electric field inside the conductor becomes 0. So this is the process in which net electric field is 0 because some electrons are shifted in this surface and some positive are shifted in this surface. So it creates an electric field inside the conductor, and there is external electric field, so these are cancelled out till this is actually what happens, this electric field inside the conductor increases as and it becomes equal to the external electric field and net effect is 0. In this way net electric field inside a conductor is 0. So next point is, so it is a very important properties that net electric field inside a conductor is 0. So next topic is it means next point is the net charge inside a conductor is 0 when you placed in an external electric field. Okay, suppose that I have a conductor and then I am saying that net charge inside the conductor is 0, and I placed this conductor in positive charge plate, between the positive charge plate and negative charge plate. You can say that I placed it inside a uniform electric field. Then what happened? Then net charge inside the conductor is 0. How I can prove it? Okay, for this we consider a Gaussian surface inside, just nearer inside a conductor, just inside the conductor. This is Gaussian surface, and I know that Gaussian surface calculate the electric flux. I know that the Gaussian surface calculate the electric flux, and the formula of electric flux is surface integral of electric field over a closed surface is always equal to total charge on the surface by epsilon naught. So this is the formula of Gauss law, and this is Gaussian surface. So I have to calculate the net electric flux inside it. And we know that when you placed a conductor inside a external electric field, then electric field is 0 inside the conductor. So if E is 0, then I can use this formula, E dot, this is the dot product, and the formula of dot product is A dot B is equal to AB cos theta. So put this value, E ds cos theta is equal to Q by epsilon naught, and we know that E is equal to 0, so this becomes 0 is equal to Q by epsilon naught, and this says that they multiply this 0 by epsilon naught, it becomes 0. So this shows that total charge inside a conductor is 0 when you placed in a external electric field. This is the second property, one of the important property, that when you placed a conductor in external electric field, then net charge inside the conductor is 0. Okay. Now third point. Third point is electric field is always normal to the surface of charged conductor. Okay, electric field is always normal to the surface of a charged conductor. So consider a surface of a charged body. I am saying that this is positive charge over the surface, and the direction of electric field, suppose that this is direction of the electric field is this, and I know that it is always normal to the electric field line is always normal to the surface. How I can prove it? Listen, suppose that if I am saying that I know that it is 90 degree to the surface of the conductor, but to prove this it is normal to the conductor, suppose that it is not perpendicular and direction of electric field is in this. It makes an angle theta with the surface. To prove that it is 90 degree, suppose that it is at an angle of 30 degree, 60 degree. Okay, so for journal I am taking theta. So it is a vector quantity, and I know that a vector quantity can be resolved into two component. Suppose that this is the A vector, and I can resolve in two component, A cos theta and A sin theta. So, and you can remove this component to two component. Okay, single vector can be resolved into two component. Similarly, this electrical component can be resolved in two way. Number one is E in this sides E sin theta, and in this sides E cos theta. Okay, so look at this point. This is electric field at tangential electric field. Okay, because at the surface it is along the tangent along the surface. So I am saying that tangential surface along the surface, its value is E cos theta. Now what is its role? It play a role that if there is some electric field, then some charge moves along the surface. Some charge due to this, if it is possible, if this is possible, then some charge moves, and when some charge moves, it creates a surface current. It creates a surface current. Then what happened? But we know that surface current is not possible in electrostatics, because this chapter is electrostatic, in which charge at rest. So this current is not possible. It means if this current is not possible, it means tangential electric field must be 0. So E is equal to E cos theta, and because E is present, so so cos theta should be 0, and when cos theta becomes 0, when cos at 90 degree, when theta is 90, so theta should be 90 degree. So in this way you can say that only perpendicular component, you can say that 90 degree is possible only in electric field. So you can say that this is the way you can prove that electric field always, it means this is not possible, electric field always possible at 90 degree. So this is the right way to represent the electric field which is at 90 degree. So come to the next property. Fourth property states that the electric potential that is V is always constant in or on the surface of the conductor. This is one of the important property. Yes, focus on it. Electric potential is always constant in or on the surface of the conductor. What is it means? It means suppose that you have a conductor and then it is, suppose that it is charged conductor, okay? Then we know that inside the charged conductor, when you placed in an electric field, E is 0. But this property, fourth point says that the net electric potential is always constant inside or on the surface of the conductor. So you can say that, how I can prove it? We can prove it by this. We know that electric field is equal to negative of the potential gradient. We well know about it, this formula. And E is equal to, E means electric field at any point is equal to the negative of the potential gradient. And we know that inside a conductor net electric field is 0. So this equation becomes dV by dr is equal to 0. We can neglect the negative sign, okay? So dV by dr becomes 0. What is this? This is the differentiation. Okay, you tell me, what is the differentiation with respect to time? What is the differentiation of 5 with respect to time? It is 0, because differentiation of any constant is 0. So it means if value becomes dV by dr is equal to 0, it means this V should be a constant. So you can say that V is constant inside or outside a conductor. Okay, now one more point, point fifth. All the charges. Now fifth point, as actually it is discussed earlier, but consider it as fifth point, that electric field is 0 in the cavity of hollow conductor. Electric field is zero in the cavity of hollow conductor. What is it means? It means suppose that you have a solid sphere and there is some hollow space inside this solid sphere. So you can say that this is known as cavity. This is known as cavity because it has some vacuums. You can say there's some space inside a hollow sphere. So this is known as cavity. And we earlier know that the net electric field in the cavity is zero, because I earlier told you that net it creates. Suppose that I placed it positive charge and here it negative charge in the uniform electric field, then what happens? One side it creates negative charge and other sides create positive charge, and in this way in these sides it creates, so net becomes E is equal to 0. This phenomena, actually this is a phenomena in which create a region inside a conductor, where electric field is 0. This phenomena is known as electrostatics shielding. Electrostatic shielding. This is a phenomena in which electrostatic shielding is what? Electrostatic shielding is a phenomena in which we create a region where the net electric field becomes 0. So this is the phenomena, okay? It has some applications. For example, one of the application is that it is advised that when you are in the thunderstorms, or there is a lightning around it and you are sitting inside a car, then what happened? It is advised to you that you are stay inside the car. Because what happened? Actually this car, body of the car is made up of metallics. It is made up of metals, and when thunderstorms occur, when lightning is occurred, then what happens? Suddenly a charge is fall over this car, then what happens? This is becomes because there is this hollow space inside the metallic body, and this space behaves like net electric field inside the metallic body is 0. So there is no injury will be happened, no any kinds of injury will be happened in this inside the car. So this is the first application, that electrostatic shielding. And one of the important application of the electrostatic shielding is that there are many kinds of instruments which are very sensitive. Mostly semiconductors instruments, electronics instruments are very sensitive. So suppose that this is the instrument and it is very sensitive for in the electric field, then it is placed inside a hollow conductor. This is known as electrostatic shielding.